Good afternoon, everyone. Thanks for joining us for today's IHSP Policy Talks webinar. Glad you guys can make it. We're just going to take a moment or two while people start to sign on and then introduce the moderator and speaker for today. In the meantime, I'd just like to thank our co-sponsors for today. So we're co-sponsored by the Consortium on Analytics for Data-Driven Decision-Making, which is led by Professor Amélie Canal-Vallée, and also the PODS program, Policy and Data Science, which is directed by Professor Nick King. So thanks again for co-sponsoring the event. Annie beat me to it. Okay, why don't we get started? Hi, I'm Arijit Nandi, the Interim Director for the Institute for Health and Social Policy. Today, I'm just going to introduce our moderator. Really great to have Amélie Canal-Vallée moderating today's session. As I just said, she's the director of CAN D3. Hopefully I'm getting that right, Amélie. And she's a professor jointly appointed in departments of sociology and epidemiology. And she's an associate member of the Institute and also the director of MOSHR, right, which is the McGill Observatory on Health and Social Services Reforms. You're killing me with these acronyms. So thanks again for doing this and good to see you again.
Thank you, Ari, and thank you so much for inviting us to co-sponsor this talk, which is really directly aligned with the goals of CAN D3, which is a training program dedicated to supporting training in data-driven decision-making and facilitating career transitions outside of academia for PhD students in population research. So this is, I'm really looking forward to this talk. But first, before I just want to introduce our distinguished speaker. So Vik Pant is a Chief Scientist and Chief Science Advisor, Natural Resources Canada, and Adjunct Professor, Faculty of Information at the University of Toronto. He is a researcher and practitioner of conceptual modeling and applied artificial intelligence. His scholarship and research are focused on conceptual modeling of strategic I knew I would mess that one up. Co-opetition in complex multi-agent systems. So I actually practiced this and I messed it up and now I did again, but that's okay. I got it now, co-opetition. And Dr. Pant's academic research has been published in numerous peer-review scholarly journals. These include the Journal of Strategic E-Commerce, the Journal of Economic Commerce and Organizations, and the Journal of Information Technology and Education. There were several more, but I think you all want to hear from Dr. Pant. So without further ado, I want to thank you for joining us and I will turn it over to you.
Thank you very much, Amélie, and thank you also to Arijit. I'd like to point out that about a month or so ago, or 2 months ago, Arijit and myself and Jennifer had what could only be described as a long and interesting conversation on many opportunities for collaboration, of which this is the first, and I hope there'll be plenty more such meetings, and we're really looking forward to partner with McGill in a number of different ways. Beyond that, also I'd like to thank Professor Amélie and also Anaik for organizing this session and sponsoring it and having me here. So I do have some prepared remarks, and I've presented this talk in anywhere from 15 minutes to an hour. So I know I have about 30 minutes for my prepared remarks, so I'll try to calibrate myself as good as I can. But I certainly want to leave plenty of room for conversation, for a dialogue. And I hope that through this presentation, you'll already start to see some opportunities to partner with us, because that's the spirit in which I come today, is to invite you to express your interest. If there's anything in here or all of it that seems to be interesting for you, for your research, for your students, happy to talk. And you know, that's one of my goals in doing these engagements, is to make sure that we connect with Canadian universities and to tap into all of the brain power and all the research competency that attends to it. I'll introduce you to something called the Digital Accelerator, because this is a concrete, I guess we can call it an experiment, but actually now it's been proven quite well, the hypotheses to the extent that they could be proven statistically significant or otherwise, that it's actually now taking off. And in our department, we've had one for about 18 to 20 months now, and this model is working really well. And now other departments, I'm talking to lots of other departments around Ottawa, around the federal family, that are adopting this model. So even if you see something that we're doing, focusing it more on natural resources aspects, you can make a reasonably fair inference that other departments in their mandates and their focal areas are also launching these kinds of digital accelerators, or are scaling them if they already have them. And so our models are very complementary and very supplementary. Okay, so first of all, I'd like to talk a little bit about what natural resources sector mean in Canada before I talk a little bit about NRCan and then go into the substance of my presentation. So when it comes to natural resources in Canada, they directly or indirectly account for about 17% of our nominal GDP, about 1.7 million jobs, give or take, and exports which are valued at over $250 billion, comprising about 50% almost of our total merchandise exports. And generally from a scoping perspective, we're looking at energy, forestry, and mining really as our three main subsectors within the natural resources industry, if you will, or the natural resources space. NRCan, so that's kind of the picture of natural resources in Canada, in the sector in Canada. NRCan, the department that I work for, Natural Resources Canada, we are the federal government department that is committed to improving the quality of life of Canadians by ensuring that our country's abundant natural resources are developed sustainably, competitively, and inclusively. So that's what NRCan is, and that's what the natural resources sector mean for Canada. So NRCan, we are an economic department, but actually we are a science-based economic department. And what that means is, and I really like the model of CANDI 3 that Professor Amelie talked about, which is the notion of integrated policy, but also integrated policy that is aligned with our integrated planning and priorities. So the policy itself is integrated, meaning it's comprehensive, it's multi-perspectival, it accounts for multiple stakeholder views and those types of things, but also that the policy is not unconnected from or disconnected from our priorities from the larger family that we're a part of in the government of Canada, and that our plans are there to enable the fulfillment of our policy mandates and the achievement of our priorities. Now, science is a very, very important part of our policy equation. Just like with the CANDI 3 model, here what we talk about is evidence-based decision-making, or insights which are surfaced through the systematic and structured analysis of data to be able to policy originate, to do policy innovation, to do policy unification, and to do policy integration. So all aspects of the policy life cycle, some way, shape, or form, data science plays a role in it. Technology plays a role in it. And NRCan, as a federal government department, we have an interesting role whereby we are performers of science. So we do science, we are users of science. And as I described, science informing other science, but science informing policy, that's a big part of it. We are a funder of science. So a lot of the science investments that we make are not necessarily just intramural or intra-departmental. These are investments we make with partners like universities, like research institutes, and those science capacity organizations, and also communicator of SNT, where it's very important that we're doing science. We want to make sure that Canadians in general are informed about the work that we do and the way that we do science. So there's a spirit of openness, spirit of transparency, and spirit of just accountability brought to us and brought to all our science partners. And as you can imagine, a lot of the science that we do and the policy that it informs, the impact, of course, our remit is on the natural resources sector, but as I'll show you, the impacts are felt far beyond just the natural resources sector. So it's really a very interesting space to be in for folks that are looking to get into science policy integration, for folks that are interested in evidence-based decision-making and how that actually maps to the process of the full life cycle of policy, right from its origination all the way to its innovation and improvement over time. Really exciting space to be is within NRCan. And as I mentioned, if you're interested, very, very happy to have further conversations with you. So let me give you a concrete example. When we talk about the application of data, the application of science, insights into the policy process, what are some examples? What are some interesting applications of data-informed policy making that we're doing at NRCan? And specifically because my team really focuses a lot on advanced techniques and technologies to mine data. So I would say that big data and machine learning would be good candidates to really talk about here. A couple of examples. First one is predicting the spread of groundwaters. So colleagues that have worked with our experts in the Geological Survey of Canada, which is a part of Natural Resources Canada, and the Canadian Centre of Mapping and Earth Observation, which is also a part of Natural Resources Canada, they use advanced AI techniques with massive data sets. And those data sets have been gathered over decades, collecting from different sensors and instruments and probes and detectors and so on and so forth to predict the spread of groundwater and floodwater. Now you can imagine, of course, this is very important from a natural resources industry perspective, but beyond just natural resources industry, this kind of insight has implications for public safety. It has implications for urban planning. It has implications for all kinds of other access to services perspectives as well, that we have downstream beneficiaries with. Another example is estimating the spread of wildfires and forest fires. So here, certainly you can imagine that from a forest economy perspective, this is something certainly we want to be able to model, and we want to be able to help mitigate and remediate and sort of counteract any negative effects of wildfires or forest fires. But here too, depending on where the fire is, the implications are not just for natural resources sector, but also from a public safety, emergency preparedness, and critical response perspective, and even long range municipal and urban planning perspective as well. These are things that are very relevant. Modeling energy yields to make sure that when prospecting is being done to tap the natural resources for their abundance riches, and all of the things that we do, we want to ensure that it's done in a very targeted, in a very surgical, and in a very scoped and a precise way. So we're not going around trying to do things to the environment which are negative. And from an ROI perspective, we have to be very, very careful that we focus on values, which includes not just economic value, but also social and governance and other values as well, to ensure that we're making these types of interventions where we have to disturb the earth, if you will, to get at natural resources, that's being done in as minimally and intrusive and as minorly as disruptive a way as possible. And the other one you can also imagine is approximating the infestation of invasive species, whether it be the spruce budworm, whether it be the emerald ash borer. These kinds of things can not only destroy entire forests and therefore the economies that depend on them, but also the ecology is upset. And there again, depending on where it is that these infestations are taking place, it can lead to various public safety, critical response, and emergency preparedness as well. So these are areas where we have lots and lots of partners, lots of big data sets, and lots of very advanced techniques being applied to find those patterns, to find those regularities in the data, to be able to then take those insights to our policymakers, to our policy colleagues, who can then start considering it and making it a part of their decision thinking. Now, what's interesting is that even though nowadays, AI is the most kind of important topic du jour if you are in the software business, but from our perspective, our researchers have actually been using artificial intelligence, even techniques like machine learning, computer vision, since the 1990s, much before it sort of was mainstream in the zeitgeist. These are a couple of papers written by our experts from the Canadian Forestry Service, who were using machine learning-based models to do object detection within images, instance segmentation, scene segmentation. This is a forest, this is a woodlot, so on and so forth. So they were publishing papers in the forestry science space, but applying machine learning techniques as far back as almost 30 years ago. Similarly, they were using sequence learning techniques, what we can call sequential learning techniques in machine learning, also back in the 1990s. So for our scientists, this topic of AI, this topic of machine learning, deep learning, etc., this is not extremely new, because our scientists had been really using this. Now what has happened is, because of the proliferation and the popularity of it, is that many more of our scientists are actually looking at it as a viable tool in their toolkit, but this is not something new. And so the nice thing about it is that our accelerator, that I'll describe in a moment, was able to really benefit from some of that deep expertise that we already had in our department to benefit from these kinds of tools. Similarly, we had the Geological Survey, which is also a part of NRCan. Our scientists have been using neural networks techniques, not necessarily deep networks, shallow networks back then, just given computational constraints and also certain other type of theoretical issues with it. But they were using deep learning, not deep learning, but neural network-based learning, even as far back as 25 years ago. So we really, and that work hasn't stopped. So ever since then, our GSC scientists, just like our CFS scientists, just like our CCMEO scientists, and other sectors in our department have used these kinds of technologies to really elevate the kind of analysis and the insights that they're doing. And throughout this talk, what I'll do is I'll not only share with you sort of a descriptive summary, but I'll also share with you a couple of insights, because now we've had 18 months to sort of look at what works and what doesn't work, and that can sort of give us an idea of the fruits of our critical reflection on the way that we've been running Digital Accelerator and the way we've been doing this. So what is the Digital Accelerator? I'm going to pause right here for a second. So about 18 months ago, I was recruited into Natural Resources Canada, and I was very happy to join. And we launched this group within the Office of Chief Scientist called the Natural Resources Canada Digital Accelerator. And this model of the Digital Accelerator is one where we have experts in data science, experts in other digital technologies as well, but let's focus on data science for the moment. We have experts in data science who may not necessarily have any kind of traditional training or any kind of background in forestry science or energy science or something like that, but they're experts in artificial intelligence. What we do is we pair them up with our subject matter experts, our domain specialists, our scientists from forestry, scientists from energy, scientists from our Geological Survey, etc., space-based Earth observation, remote Earth monitoring, and they work together. So it's not a turnkey model. It's not that the scientists have some kind of proposal and they give it to our data scientists and then they go away and they come back with a fully baked result. What happens is that they get together, the proponent, if in this case, the scientist from one of the sectors, the botanist or the zoologist or the atmospheric physicist or the stratigrapher or the volcanologist, they'll have some kind of proposal where they are not experts in data science. And so we'll pair them up with our data science experts who will then work together using state-of-the-art technology, state-of-the-art data sets, and co-create value, co-produce these artifacts that can benefit. And what's very interesting, one of the first insights I'll share with you is, quite often we think about that when artificial intelligence sort of became popular as of, let's even say 5 years ago, and since then it's been nonstop, is everybody thinks about artificial intelligence-based bottom-up models, where you have models that learn bottom-up from observations and samples and instances and such like, are completely going to make obsolete the hand-curated models that had been around for, decades, in some cases by experts, calibrating the parameters, calibrating the coefficients, and that those will all be done. And in fact, everything will be deep learning, everything will be machine learning, which is when you basically learn from data as opposed to you hand curate and calibrate models. What we actually found is that neither of them was really perfect by itself. What we found was that in many cases, there were certain scenarios where certain aspects of deep learning or machine learning based models outperformed traditional hand curated models, the top-down models. And in other cases, the hand curated models were very, very comparable in performance to the more machine learning type models. So the first insight I'll share with you is that our team started to work with these domain specialists and experts to build ensembles. So now when we make a prediction, it doesn't just come out of a hand curated or a top-down model or a rules-based model, you can call it that, or a symbolic systems model. And neither does it come directly from a bottom-up machine learning model. We actually have strategies now to make a prediction based on an ensembling or a blending of those predictions. So that's something very interesting that we found and others have found as well, but this is something that we're actually benefiting from. So that's what the team does. And I'll give you a couple of good illustrations of the kind of projects where my team of the Digital Accelerator is working with experts from all the sectors of Natural Resources Canada to advance some of these science policy integration projects. So one of the priorities that we have as a department is around flood mapping. So flood mapping, as you can imagine, is a big problem. It can lead to all kinds of economic damage. It can lead to all kinds of other problems, public safety, etc. So the Canadian Centre for Mapping and Earth Observation works closely with the Geological Survey, and they have lots and lots of data that they've accumulated over the years. We have new satellites up in the sky, which are sending even more new data. And so we collect all of this data and working closely with other government, CSA, etc. We have a fairly large data set of satellite imagery. And we also have some imagery that is not just satellite imagery, but we have fixed wing imagery. We have sort of rotary wing imagery. We have all kinds of aerial photography of the Earth. And so what we are doing now is working with them, and this project is actually open source, so you can go and look at GitHub and you can do a search on your favorite search engine and search for Geo Deep Learning NRCan. All our code is publicly available. So what we do is we've trained these ensemble of neural networks that take satellite imagery and can, down to a pixel level, assign 17 classes, one of 17 classes down to a pixel level. So you can imagine that if you have a satellite image that comes through using extremely well-trained models, computer vision models, we can now say that pixel correlates to a body of water, that pixel correlates to the top of a building, that pixel correlates to the top of a tree. And that once you have that kind of features extracted from the satellite imagery, now you have a map that you can use to make all kinds of other decisions beyond just making models of floods, that when floodwaters will sort of rise, when the floodwaters will recede, although that's the primary intention behind this project. But as you can imagine, once you have that kind of intelligence extracted out of satellite imagery in very high precision manner in a fairly quick turnaround, then that information can be used for all types of other scenarios, including but not just limited to flood mapping, right? So that's one of the projects that we're working on. It's available. You can see our progress, and we're always looking for partners. And so GitHub is one of the best ways to partner with us. And of course, you can partner with us also through the Accelerator, where you can work directly with us as well. By the way, GitHub is a public code repository where people can upload their code, and then other people can collaborate on it, and so on and so forth. Another very interesting project that my team is working on is related to a government priority of a network of EV charging stations from coast to coast to coast. Now, you can imagine that the best way to figure out where to put them is not to put them equidistant, because that's not how EV charging behaviors are to be expected. But what we need to figure out is, where do people live that own electric vehicles? Where do people work that own electric vehicles? What kind of routes do people take when they go to from their home to their work? What kind of shopping malls do people go to that have electric vehicles, typically, that park their cars while they're out shopping? So there's lots and lots of different sets of data that can inform, if you will, this geospatial recommender engine, if you think about it like that, where you have lots of data coming from, well, NRCan has lots of data, but also working with our partners at Transport Canada, who also have massive data sets, working with partners in the private sector, so organizations that actually make electric vehicles. And so they have lots of deep knowledge about how those cars are driven, where they're driven. Obviously, records are anonymized and de-identifiable, but they have lots of very ground level data of how those cars are driven, where they're driven from, driven to, when they're charged, how often they're charged, where the electricity grids are, what the architecture of the grid looks like, physically, spatially, etc. So building this multidimensional data structure first, where we can build this large kind of set of features, if you will, that describe this notion of electric vehicle charging behaviors on the part of people, and then putting that on top of a latitude, longitude coordinate system, so we can then make a recommendation as to, okay, it seems like this, and this place are the right places to be putting EV charging stations, and here's the reason why. We certainly want there to be a degree of explainability. So if somebody asks, hey, why did your recommender engine ask you to do this or make this recommendation from a policy perspective, we want to be able to interrogate the model or the algorithm in some cases, or the prediction, to be able to say, well, this is why it actually said you should do this and not that necessarily. Okay, so that's another interesting project we're working on. All these projects are multi-phase. It's continuous improvement, it's continual learning. So we never say that everything is completely done. I mean, there's always new data that come in. There's always new algorithms that are introduced in the research community, in the academic community. So while we deliver on milestones and we have certain objectives of what software artifacts to enable our policymakers with, but from our perspective, it's always a process of continual improvement. And so while things may go off cycle for some period of time, but we always keep an open mind as to some new algorithm being produced or some new data set being given to us or something like that. And then we go back and we can just sort of refit our models to the data and then improve the prediction. Another interesting one that we are working on is called Energy Star. So you may be familiar, there is a something called the Energy Star symbol. It's a symbol which you can attach, or manufacturers can attach to devices that comport with certain Energy Star program requirements. What happens is that these requirements have changed over time. And very often what also happens is that manufacturers, when they have certain SKU numbers, when they have certain identifier numbers on like a washing machine or a refrigerator or a dishwasher or something, when they go to a retailer, the retailer may change that SKU number a little bit. They may add some vendors or some reseller specific extra bits or extra kind of identifier to that. And so what happens is, from a validation perspective, we want to make sure that only devices which are actually Energy Star compliant are being advertised as Energy Star compliant. So this is a non-trivial problem because, first of all, there are lots of e-commerce websites where people are advertising all kinds of appliances and all kinds of things that can potentially be Energy Star compliant. And also then you have the issue where, for example, those SKU numbers may be changed. So the master database that we have access to, the SKUs may not match. And so there's all kinds of other things that have to be done. So my team is basically working with experts from our low carbon energy sector to build an artificial intelligence, if you will, system that we call it the Energy Star Detective, which can go out and can sample these Energy Star devices which are being advertised on e-commerce websites within Canada, and then potentially flag erroneous or potentially misleading use of them. So very interesting problem where we're using different types of artificial intelligence techniques to do fuzzy matching and to do image recognition and to do object detection and all kinds of interesting things. But as you can imagine, that the findings that come out of a tool like this really reduce the search space for our human inspectors to want to go out and actually do actual inspections to say, hey, no, like looks like this was a mistake, or looks like this was being done intentionally or something like that. So very exciting project. Again, lots and lots of data that NRCan has access to, but also data that we get voluntarily from our partners, whether they be in other government agencies, departments, or whether they're from the private sector or research institutes. So here I want to share my second insight, which is that the first insight that I shared with you was we don't do the turnkey model. So we have our data scientists who work closely with the policy experts as well as with the domain scientists to co-create these software artifacts so that there's a win-win. But the second part of it is, the second insight I want to share with you is that the same thing applies to data, is that it's not as though NRCan has all the data that we have to be able to build these kinds of models or these kinds of prediction machines, if you will. So we really rely on our partnerships. We rely on a model of trusted and known exchange mechanisms where there is a proper line of sight on whoever gives us data, that we only use it for the reason that we use it for, but also vice versa, that there is some kind of value proposition on the other side for the parties that are contributing data to these kinds of projects to help them in the long run as well. So very interesting to note that every time we get a new data set, we vet it, we try to figure out what its value is, not just to the application for which we're acquiring those data sets, but also to our larger portfolio, because data is very idiosyncratic, they're very peculiar, and the notion of value is very much grounded in their utilization, in what kind of use they help you to achieve. So that's a very interesting exercise, and if that's something you want to partner with us on, that's a project that I'm actually working on with my team, which has Government of Canada-wide relevance, which is essentially how do you actually come up with a socio-technical measure of the value of a data set. And of course, related to that problem, but not the same as that problem, is the value of software or the value of digital artifacts. Anyway, so that's something I want to share about this project. Another project that's quite exciting, we're working with Canadian Forestry Service. And as you know, this year field season is obviously very problematic. And last year, because of COVID, our forestry scientists, like many scientists all over the world, weren't able to go out into the field. And many of these data sets that we have are longitudinal data sets where, certain trees, those data have been collected for, 50 years or more. And so having gaps and holes in those data sets are unfortunately very problematical for long range longitudinal studies. Also, we have an issue where the provenance of the quality of all the data that we have, and this is a problem all organizations have, especially as you grow your data sets by agglomeration and accumulation from various different sources and parties, is what happens is that some data are collected by our forestry scientists who have the equipment, they have the knowledge, they have the expertise, they have the specialism, but other data sets are submitted by citizen scientists. And there is a wide spectrum of the precision or the quality or the reliability of those data. So what we did is we worked with our team our team in the Accelerator, worked with experts from the Canadian Forest Service to, if you will, build an artificial intelligence informed data quality assessment tool. We're looking at the known records that were gathered by forestry scientists. So we know that these statistical signatures, if you will, these are the identities of good records. We use that, which is about 30% of our overall data set, to score the rest of the 60 or 70% of our data set, so that we're not discarding all of that 70% to have a high quality data set. We were able to actually train our model on these golden records to be able to score the individual records in that sort of the citizen scientists and other source acquired data set for which we were not necessarily in control of the provenance. And so we were able to save a bunch of those 70%. We were able to save, I think, close to 40 or 50% of those records for the highest quality standards for policy analysis. So lots of exciting applications of artificial intelligence to solve our business problems or our departmental meet our departmental objectives. And this brings me to my third insight, which is, and this also then connects to my second insight, which I just shared, is that what's very exciting about this is that when we started about 18 months or 20 months ago, everything was exploratory, everything was experimental. And certainly a lot of data science is by its very nature experimental and exploratory. But now a lot of that has actually, as we've kind of learned the ropes and as we've done a lot of these projects now, we've realized that what are the ingredients of tying the parameters or the goals or the design of data science work to the strategic priorities and plans of our department. So not only have we learned to do individual projects well, one by one, in partnering up our data scientists with our domain specialists, but now taking a step back and looking all the projects that went well and some that were not as good as the other ones were, we were able to understand the positive and the negative cases, where we were able to say, okay, so going forward, now we know what kind of projects we can add value on and what are the kind of projects where this may not be the right time for us to take on board. So just a couple of examples. If you ask me, I have a slide deck with many more examples. Happy to send them your way, and you can take a look at them at your leisure, and you can let me know. So okay, so I have a couple more minutes remaining, and I'm gonna go through these slides a bit faster, if you can believe it. So I talked about the first pillar of the accelerator. That was to do these value co-creation type projects, creative application of innovative technologies to advance science policy integration by having our data scientists paired up with domain scientists to build those ensembles of top-down and bottom-up models to really elevate the quality of predictions and quality of recommendations coming out of our analysis of data, number one. But the second thing was to do this not in a way that essentially creates these silos of competency in the department, and then everybody else is kind of by themselves, right? So what we did in the accelerator is, while I hired a lot of data scientists, really top level data scientists, I also then and these were mostly folks that came from outside the government of Canada, I also hired a number of folks from within the department who had that institutional embeddedness, who had the organizational memory, who had, most importantly, the professional connections to the rest of the department, whether it be HR, whether it be the sectors, whether it be the policy shops, whether it be the corporate shops. And so that way what we did was we started to do, in addition to these projects, we started to do a lot of these interesting interventions. And not everybody wants to become a data scientist, and nor should that be an aspiration for everybody, I'm sure, like any profession out there. But we wanted to at least create the space where creative collisions of ideas could happen, where people could come to a safe, welcoming, inclusive space and share knowledge and get to learn from each other. So I'm not going to go through all of them, but one thing I want to share with you is something I had started before I ever joined the government called the Synthetic Intelligence Forum. I launched it in Toronto. And then when I came to Ottawa, I brought it to Ottawa. So we started convening these events where we had academics, we had people from the government, people from the outside who came into a room together and started sharing their experiences on a topic of interest, on some kind of theme that resonates with everybody and things like that. So we did a number of those talks, and then the pandemic hit. So we had to kind of take our show on the road, if you will. So now we're doing this on YouTube. So we did a session where we had somebody from Statistics Canada, National Research Council, we had somebody from Microsoft, we did another event where we had somebody from Agriculture Canada, somebody from Accenture Canada. So really creating this space where government officials can come together with academics, can come together with private sector colleagues to really share ideas about keys to developing successful AI strategies, privacy and artificial intelligence, and those kinds of important topics that affect us all and have big implications for all of us. So on the knowledge side, I'm just going to use that example, but on that slide deck, which I've sent out, there's plenty of other examples of the kinds of lunch and learn sessions, ask an expert sessions, birds of a feather sessions. So we're doing all of that on an experimental basis in NRCan. Some approaches work, some don't. And so we quickly learn and we adapt and we keep moving forward to continuously provide our colleagues with a platform for knowledge sharing and collaborative learning. Next thing I want to quickly talk about is strategic partnerships. So this was another pillar. First pillar was, projects. Second pillar was sort of culture. The third pillar is this partnerships pillar, where what we did was we partnered formally or informally with a number of different experts around the table, because I always like to say nobody knows everything and everybody knows something. So NRCan, while we want to lead in various areas, but we know that there are other areas in data science, in digital technology, in software, in that creation and realization of organizational value by the creative mining of massive data sets, we partnered up. So with someone like Mila, we have an official relationship. CFAR, we have an official relationship. Same with Mars, Vector and Amy, we have a bit more of an informal relationship. Microsoft is a formal relationship. So we're very flexible. Like some organizations are comfortable partnering one way, others are comfortable partnering another way. So what we do is whatever works, win-win, synergy, complementarity. We just want everybody to kind of succeed together. So we have lots of these partnerships. One of them that I have, which I'm very, shall I say, happy to have launched within NRCan, is with my PhD supervisor, Eric Yu, and my former PhD colleague from Surush, who went and joined Google. So they came up with some very interesting frameworks as a part of Surush's PhD around how do you actually take machine learning models and the design choices around artificial intelligence systems at the design stage, so at the requirement stage, and how do you map them to organizational priorities and plans. So that's exactly one of the missions that I have in NRCan, is to be able to disambiguate and unequivocate on that goal. And so seeing that this kind of work had already been started, we were able to partner with them. And now we have a number of really interesting insights which are coming out of that. And working also closely with other departments like Statistics Canada, who have this need. All departments have this need. So really just trying to build something that everybody can benefit from collectively. And the last part of the pillar I'm going to share with you today is what I call capability. You can think about this as governance. We were not intended to be like some kind of a secret lab or some kind of a special team that basically did everything under the covers and then kind of just came up with these results and impacts. We want to make sure that everything we do in the accelerator is transparent, that our colleagues, our executives, our working level folks, they all know what we're doing. They understand how we make decisions. They understand who we partner with, how we partner with them, why we make those partnerships, why we select projects, why certain projects are not the right time. So we did a lot of documentation. We did a lot of consultation. We got people's feedback on how this team could be successful, what this team needed to sort of look like, how this team needed to operate like. And so it's really been accepted and embraced in my department, because had we kind of done it as that model of, hey, we kind of do our own thing in a corner and, just give us your requirements and we'll do a turnkey and give you back a working product, that is not scalable. And eventually I want this to be embedded in the DNA of our organization. And I've been talking to lots of colleagues across the government. I've been talking to Dr. Mona Niemer, and, we're going to do a kind of a series of working talks about this kind of model and how others in the government can apply it. I've talked to our federal CIO, CTO, all colleagues, and it's been very well received, mostly because of this reason, that it's easier to hire a bunch of group of very smart people and then start doing these projects that are very exciting and can lead to impact, and you can demonstrate the results. But to scale it, you need across the board kind of consensus. You need everybody to see that this is the right model. And so this is what I call AI capability, where we did everything. We tried to map it. We did, everything that you can do to map it to our integrated planning processes on the corporate side, making sure I work closely with my CIO, who's been a partner of mine, working closely with my chief data officer in the department, who's a partner of mine. So really, this is something I wanted to share with you. And last but not the least, I cannot do a talk without sharing what I am most passionate about, which is the entire technology stack that we use to make all of this happen. So we use all state-of-the-art languages. We use all state-of-the-art computational platforms for deep learning, machine learning. We use all very, very exciting cloud-based services that government agencies are allowed to use. We also have our own high-performance computing setup, where there are certain workloads we cannot put on the cloud for obvious reasons of security and national security and whatnot. So for that, we have our own stack of high performance graphical processing unit endowed machines, which I miss now that I'm in Toronto nowadays, and these are in my lab in Ottawa, but we still connect with them through VPN. Anyway, so lots of exciting stuff. I know I went 3 minutes over. I apologize for that, but happy to take questions, and I can stay past the scheduled time for this meeting, and happy to have a dialogue. But I'll just end by saying this is just the tip of the iceberg, and I really hope that we can continue this conversation. And however you want to partner with us, look at our website, contact me directly. I'm more than happy to have this conversation continue in a positive and productive way. So thank you to everybody for listening, and I appreciate your attention to this talk. Thank you.
Thank you so much, Dr. Pant. So we have some questions already that came in while you were talking. I'm going to start with the first one from Ellen Rowe. My question is based on your slide on big data and machine learning. You talked about using big data for predicting models of the spread of groundwater. Is this real-time data, or is there a delay in accessing the data set? I am aware that data collected through surveys often takes at least 1 year before researchers can use it in their projects. Thank you.
Yes, absolutely. That's a great question. I really appreciate that question. And essentially, what's interesting is that any of those examples that I used, especially the big examples, it's actually not one model. So there are multiple levels of models. And exactly as you said, there is a periodicity with which we can access certain data sets. So in certain cases, in very limited scopes, we do have access to data which are, I wouldn't say real time, I wouldn't say true time. I would say that the latency and the lag is not as much as the annual surveys which you described. So depending on the periodicity or the frequency of which we have access to a data set, that's what we've trained the models on. And so it's actually a catalog of models that we offer to our scientists. And depending on the type of problem that they're trying to solve, they can pick one or more of those models to answer their questions.
That's wonderful. And certainly very sustainable as an approach, or like very efficient, absolutely. So I have some more questions, and I want to encourage folks to either raise your hand using the little emoji, or you can also write your questions in the text box, in the chat box, and I will read them. You're also welcome to unmute and ask your question, and so we can go there. Some more questions here from Samira Rahimi. Can you explain more about your XAI techniques? Are you using it with neural networks? And what are the next steps for you?
Yes, that's a great question, and so thank you for that question, Samira. Really appreciate that. So what we do is, in the very beginning, we used to, because I had hired a brand new team, the first thing we did was we did a bit of an informal survey within the department to understand what is the level of current proliferation, much before our team ever showed up, of machine learning competency, tools and techniques. As I showed you examples, there are scientists who for 30 years have been using certain techniques, but that's not certainly all the thousands of scientists. What we found was that in many cases, statistical machine learning techniques were quite well proliferated throughout the science cadre, and they were familiar with it. They were using it in different ways and then building those ensemble models with hand curated as well as on to bottom up learners. What my team did when we came in, and again, we're not the first ones to do it, but when we came in, we really brought a couple of interesting interventions. So one is we started building a lot of deep learning based, so neural network based approaches. But if you think of neural networks as function approximators, we applied neural networks to do machine vision. We applied neural networks to do graph-based analysis, which is more relational, inductive bias-based learning. We did other types of time series analysis, like in the CFS tree ring data set. That is a neural network which is calibrated for doing sequential data sets. We did that. Increasingly, we are looking also at reinforcement learning, which allows us to actually have sequential decision-making under uncertainty be a type of problem that we can solve, because we do have some historical longitudinal data sets on which we can do what's called back testing. So we can have an agent starting from back of known truth and sort of train these. So statistical machine learning was quite well understood in my department, I would say. What we have kind of brought to the table is a application of deep learning, deep reinforcement learning, and reinforcement learning to all kinds of applications.
And I was muted. We have to have at least one of those moments. Samira has another question, and this is the million-dollar question. So getting to some of our bread and butter here in EBOH and in the Faculty of Health and Medicine and Health Sciences, healthcare data. So the data sets that you are using might not be as sensitive data as patient data sets. This will facilitate your work on using data-driven decision methods. Do you have any insights on how we can facilitate access to data sets in healthcare and therefore move AI work in healthcare?
Thank you. That is an excellent question. That is a great question. So I've had this conversation with our federal CIO and the CTO, and I'll share with you their insight. So in the government of Canada, on a global stage, as I'm sure folks are aware, we are amongst the best performers when it comes to a responsible application of AI. Now, within government, I mean, certainly one can talk about should the government have a role in regulating all AI. That's a different conversation. So the government of Canada, about 3 years ago, introduced a directive on automated decision making. And that directive, essentially, which is publicly available, spelled out the norms, the ethics, the values that are associated with applying artificial intelligence to do any kind of analysis. Then it was followed by what's called an AIA, because it's one thing to have a directive, but how do you figure out as a scientist or as a computer expert whether or not you're complying with those policy directives. So they launched a public website called the Algorithmic Impact Assessment Tool. So what you can do is you can go to AIA, you can essentially enter the parameters in a stepwise questionnaire, and depending on how you answer a question, it determines the rest of your question trajectory. So you basically answer questions, and it gives you a risk score. That risk score is determined by the way you've answered questions, and the risk score is then accompanied by mitigating factors. So they can say, okay, look, your risk level is medium, and if you do these, and these things based on your answer, then you can drop it to low or what have you. You're exactly right, Samira, in your question. When it comes to data that involves humans, subjects of any kind, by default, the risk threshold would be different than if you did not have humans involved, but that is the first step. So you're right. In our case, it's not so much the issue of privacy or confidentiality that's the big thing. It's the national security implications of some of the data sets that we have access to. So I don't want to conflate the two topics, because you've asked, because of course you may have a situation where there is the privacy and confidentiality need and the national security need coming together. But I think as an analytic lens, we keep them separate. You're exactly right. Health Canada, Public Health Agency of Canada, the kind of work that they do, even Employment and Social Development Canada, the kind of analysis which they do is very much in that realm. We also apply the AIA, just to be clear. When we have a project that we're working on, we also run it through the AIA to figure out what the risk profile of it is, even though human subjects may not necessarily be involved.
Wonderful. I think, yeah, that gives us food for thought. Certainly, national security is also a very, very high order. I have a couple of questions are lining up now. So from Bertrand Stoffel, thank you so much for your presentation. I think we all share that sentiment. Beyond the use of AI, big data, and policymaking, do you have any insights as to how it impacts trust or compliance with policies, e.g. compliance trust with zoning in flood areas? So putting the data out there is helping out.
Absolutely. And I want to answer this question at two levels. One is a technical answer, which I'm more than comfortable giving, and the other is a more functional answer, which you can decide on how good of an answer I give you. So on the technical side, for sure, I mean, trust is important, and even in the, anybody we talk to in government, the irrespective of what risk rating you get out of the AIA, there is always a question about risk, always a question about trust. What is the provenance of the data sets that you had, right from the ingress stage all the way to the use of the predictions on the egress stage. What if there's a model trained to do prediction for one purpose, but now it's being used for a completely different purpose, right? So certainly trust is a very important topic. So I'd like to address it in a technical way by saying that in our team, we look at the notion of explainability, interpretability, and fairness very, very importantly. So one of the critiques of the kind of algorithms which are used quite a bit nowadays is that they are sort of the black box, right? But the question is, how do you turn it from a black box to a gray box, if not to a white box, right? So there are explainability techniques, there are interpretability techniques where if you can do it for a whole model, that's the holy grail. But if you can't do it for a model, can you at least interpret a specific prediction? You can't explain the whole model, but you can interpret a prediction. So my team, when we train our models, that is something we're cognizant of. The other piece of the equation is on the fairness side. So how do we know that the data set that we're using is not just from a statistical perspective, that it's not undersampled or oversampling classes, but that it is actually not biased in some other way? Because remember, we're not working with health data, but in many cases, we work with data that involves communities, our indigenous communities. So we're working with data sets, with what are energy needs in those communities and so on and so forth. So we want to make sure that there isn't some kind of bias introduced into our analysis as a result of unforesighted kind of data or algorithmic application. And on the functional side, I would simply say, we are following very closely the notion of data trusts. There is a big conversation that is being led by Statistics Canada, where they are laying down the rubrics for having a trust that is a hub for all of the data sets that different departments have. It is my team is a part of that conversation as well. But so there's a technical way of looking at this problem of what are the tools and techniques available to ensure that our AI is debiased, it is completely fair and not privileging something over the other, and also explainability, transparency, privacy. On the bigger question of trust as a more socio-technical construct, yes, there are conversations where NRCan is taking part to be a partner of that coalition where we can interconnect our data sets in a way that is responsible and respects all stakeholder intentions.
Thank you. We have Ellen Bro who wants to ask another question.
Hello, thank you very much for giving this talk. Even your answers have definitely been very helpful in answering some questions as we go. I wondered if you would talk a bit more about you mentioned a top-down approach for prediction methods. I'm looking at AI for my final research project at McGill, but I'm not sure what you meant by that. Could you explain it a little bit more for those of us that are kind of new to the subject area?
Yes, happy to do so, and thank you so much, Ellen. I really appreciate the question. So essentially, when we think about artificial intelligence as these prediction machines, at the end of the day, what we want are these rules, this logic that when you give it certain inputs, it gives you certain outputs. So now the question is that thing in the middle, that set of logic, that sort of ensemble of logic, or that set of rules, where did it come from? So when we look at the traditional framing of AI from the 1950s and so on and so forth, it was more symbolic system AI, right? Where you had mathematical formalisms, where you were essentially constructing these cascades of logic that a human or multiple humans were co-creating together. And then that was your logic, that given certain inputs, they would get sort of processed according to that human created set of rules. That's why we call it top down, is basically humans are sitting there with their brain power kind of coming up with this logic and then giving you some kind of an output. The machine learning view or the data science view is sort of the inverse of that, where rather than some human sitting there and coming, or group of humans coming up with that translational logic to go from inputs to outputs, you're giving the system lots and lots and lots of samples, lots of observations, lots of historical data, and then applying the algorithm to it so it can externalize, it can generalize, it can extrapolate and interpolate in many cases what those relationships are to go from inputs to outputs. So what it happens in NRCan is, flood mapping, forest fire mapping, pestilences, etc. Much before the machine learning tsunami, if you will, those types of models were, even think about weather, my colleagues at ECCC, Environment and Climate Change Canada, those meteorological models were like created over decades with hand curated sort of coefficients for parameters, right? The coefficients for each input feature. And now you have massive data sets that you can mine to augment and to supplement and to complement that logic hand curated kind of model with the bottom up learned based model, and then have a prediction that blends the benefits of both. So I hope that answers your question, Ellen. Send me an email. I'm happy to have another one-on-one conversation with you too, if you so wish. Happy to do it.
That's a fantastic offer. So we might take you up on it. We have another question from Nadia Lefter, which was actually a question that I was going to ask you as well, that I had noted. So thank you for a great presentation. I'm curious about the role of other team members who are not data scientists and how important their work is. For example, project managers, lawyers, public policy experts, sociologists. So my, I guess, tag on question was, you're producing very sophisticated information, and how do you move that along, which I think is related to Nadia's question.
Yes, a great question. Thank you, Nadia, and thank you also, Amelie, for articulating the question. So I think the first thing is recognition. I think a lot of times advanced technology interventions fail, not because of the technology, but because of the lack of social analysis. So the first thing is that from the very first day when I came in, I told the data scientists and I told the non-data scientists, we're all equals, everybody's in this together, and at the end of the day, a rising tide is going to lift all boats. So failure of our projects will very likely not be a technology-driven failure, because these algorithms are used by the world's biggest government agencies, the world's biggest companies. So we don't have such an idiosyncratic need that we're gonna break it past its usage. So where these things are gonna fail is gonna be because of the human factors. And two things. One is human factors on the project itself. Make sure there's transparency, make sure there's proper teamwork, make sure there's proper collaboration and competency. I like Arijit's comment on sort of this notion of competence, or the notion of capability. Let's just make sure that we all work together as a team and come together. And then there is the subject matter piece, which is ensuring that all views are welcome, no view is privileged. And I have another priority in my department, in my current role, which is that how do we better braid and weave the Western scientific method with indigenous ways of knowing and learning. So this is a priority in all government departments, and it's one that I contribute to along with my colleagues from the Indigenous Affairs and Reconciliation section. So that's the thing. So there is on a per project collaboration basis, that is something you have to kind of walk the talk, is that everybody's being treated fairly, all views are welcome, and everybody is adding value to the project as a whole. And on the substance side, on the content side, on the subject matter side, also recognizing that we don't know what we don't know. So more voices are certainly better in the analysis. And that's how our data sets from a technical sense have grown, is when we've realized that somebody has come from a sociological background or an economist background or even a public health background and said something to us that has then sent us on a chase for some new data set. And sometimes it elevates the quality of the model, other times it don't, but at least we know we explored that avenue. At least we tried it.
That's wonderful and really inspiring, really, for your community. So Ari has a question, and then I have a last one probably to close off. So I think Ari says, great presentation. I did ask him to take it out loud.
Should I all right, fine.
Spot.
I'll unmute. I'll unmute. It's fine. Thanks, Emily. You're doing a great job of moderating, so I like to. You know how I am. So anyway, Vik, yeah, great presentation. So my question was about one of your last points about AI capability, and it's important, kind of the importance and the critical part about getting buy-in and consensus from the other sectors if you want to see scale up, right, of some of the insights and lessons learned through these really sophisticated analyses. So I was kind of curious about some of the challenges that you face, because of course, when you think about your interactions with the other science advisors, they might have different values and judgments that they bring to this, different interpretations of the results. Does that complicate things? And then, of course, I'm kind of curious about how much you engage with some of the political factors where maybe the evidence, you see that there are kind of barriers to the implementation of some of the insights that you gain, and kind of what do you do in those situations?
Yeah, that's a very interesting question, Arijit, and thank you for that, and thank you for your very gracious and kind invitation. Happy to come and happy to come back anytime you want me to. I would say the following. So I think it's important for the accelerator, when we set it up, to define the boundary of what we are, and equally importantly, know what we are not. Because I think that we knew that when this accelerator was being set up, and you can always do more and you can always have more resources. What we realized is that already the lift in front of us was so heavy that we wanted to make sure that let's know exactly what is expected of us, because otherwise we're setting ourselves up to fail. Otherwise we'll end up over-promising and under-delivering. So what we do, Ari, is that we essentially bring the expertise when it comes to the data science, the digital technology. The problems are being brought by, or the problems to solve, if you will, including the data sets in most cases, are being brought by our domain experts or our policy experts. They give us the data, and as I said, we work together. We come to conclusions. Now, so as long as the technical metrics of the models that we're trying to train satisfy our partners, who are our clients, if you will, our internal clients, it's for them then to use that model to apply on the scaled up data set, and whatever inferences are drawn from that, they then take it forward and bring it into our policy leadership. So we just focus on the execution, the implementation, and to the extent that through working in this kind of model, through the process of osmosis, people do end up getting that sense of the cultural aspect of being data centric that comes out with it. We've not really had any issues with policy advice per se not being accepted or otherwise, because what we're doing is anything that comes out of our shop is backed up by proper rationale, proper justification, and then it's ultimately the scientists on the sector side who work with their policy advisors who then put it all together and then elevate it to our policy leadership.
Thank you. So I have one closing question. I'm going to take chair's prerogative or moderator prerogative to ask you, for our early career researchers that are interested in joining the public sector, what skills would you consider important to develop to support science and policy integration, such as the one you do?
Yes, that's a great question. Thank you, Amelie, and thank you for a phenomenal job of moderating and sort of keeping everybody on track. That's great. I would say really three things. First of all is I would say that really a left brain, right brain thinking unison, I would say, because oftentimes what happens is that people come into the public service, and I noticed this too, is there's just so much to do and so many interesting projects to work on that people start to focus a bit too much. I mean, focus is obviously very important, but you want to be able to apply the analytical brain with the creative brain, kind of the data-centric brain with the non-data-centric brain to really understand the problem in a holistic sense. So I would say the first thing is the person really needs to not be coming in with a closed mind in terms of interpretive techniques or analytic methods. They need to be somebody who's comfortable bringing in new ways of thinking to the table, whether they know them at that moment or not, and learn from others. So that's the first piece. Second piece I would certainly say is a consensus builder, because I think that's one of the things which I really enjoy in government, is that you really get to work with a lot of people and you hear their perspectives, you hear their insights. And in fact, that's where some of the learnings on the previous answer, which I just gave you, comes from as well. As somebody might say, hey, look, have you thought about this approach? Have you thought about that approach? So being that consensus builder, at the end of the day, yes, if there are lots of approaches and you need to land on something, you need to land on something, but it's not sort of by fiat. It's not by telling people, it's sort of by building that groundswell of mutual support for some kind of an initiative. And the third thing I would say is adaptive and adaptable to change. Because what I noticed is, I came from a career in the private sector working for mega software companies. I went to a startup accelerator, and then I came to the government, and all that while I used to think that, government is slow and government kind of moves at a glacial pace and government doesn't change. And when I came in, I realized, government is actually what I call an n-speed architecture. So there's some pockets of government that by design and by necessity are resistant to change. And that's how, these are systems around national security and public safety. I mean, these are systems that you want robustness and rigidity and dependability on. But then there are things which are moving as fast as, if not faster than, in many cases, the startups that I used to advise before I came to the government. So it's recognizing that in government, there is this n-speed architecture. So depending on your appetite for change, driving change and being driven by change, calibrating yourself and getting in the right lane. So in the accelerator, we move fast and we do a lot of projects and design thinking, agile thinking, fail early, fail fast, get up, try something new. But then certain other parts of our department, they focus on other kind of analysis or other kind of policy work. They operate at a completely different space. So everybody can find a pace in government that adapts and is amenable to their success path. And that's why having a mentor, I would say that, I know you asked me for 3, but I'll say the 4th one, which is coachability, is come in and look for a mentor. That's the most important thing. Find somebody who will take you under their watch and who will teach you how the government works. And then that's really going to help you achieve the first 3 things, which I just mentioned. I know I snuck the last one in there, but thank you for the opportunity.
That's fantastic. And indeed, I just want to end by thanking you on behalf of all our organizations that co-sponsored this for very much for this most engaging presentation, and your your generosity in sharing your insights and expertise. And just on a personal note, I think I'm coming out inspired to know, and because I know it with my partners as well, but with your demonstration that our government is so open and at the cutting edge. And sometimes people have this impression that data science is only available to the highest bidder, and that would leave out organizations like government that have the public good most at heart. And I think I'm coming out of this with a renewed sense that that's not the case, and that we're there, and definitely the insights are there and they're being taken up, and the intelligence is moving up the decision ladder. So
thank you.
It's a very bright future that we're looking at, and thank you for being a part of it and
very
ushering
kind. Thank
me
you
there.
for your gracious invitation, and I'm happy to come back whenever you want. Thank you. Thank you, Arijit.
Thank you so much, and thank you everybody for your questions and your engagement. It was a pleasure to have this lunch talk.
Yes.
Thank
Bye-bye.
you all, and have a great day.
Yes.
Thanks, everyone.
Bye, everybody.